Okay, so I'm just going to be working through the Algebra 1 A1 2.5. That's the lesson, Exploration and Practice 2. And really what this is dealing with is some inverse variation functions. And so I just wanted to say really quickly that an inverse variation function is of the form y equals k divided by x. Okay, so an example would be something like y equals 2 over x. Or y equals 5 over x. And so you can see here's an example, y equals 12 over x, where we have a relationship between two things. And generally what happens is as one thing increases, the other thing decreases. So there's lots of examples of where this might be used, so speed and time are inversely related. If you have a constant distance that you're traveling, maybe you have 12 cookies and you're going to break them up amongst, different numbers of people. And so the number of people and the number of cookies they get would be inversely related. So there's lots of things that would work here. And so what we're going to begin with is number one, where you're basically just substituting in a number for one of the variables and then finding the other variable. So let's check for A. So it says find y if x equals 3. So first of all, I'm just going to write out my equation, y equals 12 over x. Then I'm going to take that 3 and I'm going to plug it in for x. So I'll get y equals 12 over 3. And then I can just simplify and get y equals 4. So that's not too bad. I can just plug in the 3 and out comes the 4. Now this one says find x if y equals 2. So again, I'm going to write out my formula, y equals 12 over x. But now this is a y value. So I'm going to plug that in for y and get 2 equals 12 over x. Now 2 equals 12 over x is the same thing as a proportion. 2 over 1 equals 12 over x. Right? And so then I can use my strategies for solving a proportion to find x. So I could flip both sides and I could say 1/2 equals x over 12. And then since I have x divided by 12, I could multiply by 12 over 1 on both sides. Then this will divide and I just have 12 over 2 equals x, or 6 equals x. Okay, so in the case of plugging in x, it was pretty easy to find my y value. But in the case of plugging in y, I had to actually do some solving to find x. Okay, so I'm going to let you work on C and D because you've got a model now. So you can follow a similar model. I'll also put up a key, but I don't want this video to be too long. So let's look at number 2, which is a little bit different. It says two quantities, x and y, are inversely proportional. So that means y equals k divided by x for some k value. Okay, so up here, we knew what the k value was. It was 12. So we knew how these two things were related. So that might mean, oh, there were 12 cookies. And then if we have 3 people, they each get 4 cookies. But coming down here, we don't know what the number of cookies is, or we don't know what the distance we're traveling is. We don't know what that constant of variation is. We don't know what that k value is. So we have to find it first. It says find k if x equals 8 when y equals 4. So this is kind of like what we did up above, except for in this case now, we have to write out our equation, y equals k over x, and we have to plug in two things. We have to plug in 4 for y, and we have to plug in 8 for x. So if we do that, this means, this little arrow that means this means, we would get 4 equals k over 8. Now again, this is a proportion because 4 is the same thing as 4 over 1, and a proportion is a fraction equaling a fraction. So now we should be able to multiply by 8 over 1 and multiply by 8 over 1. This will divide, and so now I just have 32 is equal to k. Okay, 32 equals k. Write your new equation with the k value you found. So again, we had y equals k over x, but now we can plug in 32 for k and get y equals 32 over x. So that's my new inverse variation function. So that 32 is my constant of variation, which might be, the number of cookies I have, or maybe the distance that I'm traveling. Okay, so let's clear that and scroll down. So use your equation to find the missing coordinate for 16 comma y. Okay, so remember our equation was basically y is equal to 32 over x. So we were given the x value and we want to know the y value. So let's plug in 16 for x and we'll get y equals 32 over 16. So y equals 2. Okay, so that's our missing coordinate and the point would be 16 comma 2. Use your equation to find the missing coordinate for x comma 40. So y equals 32 over x was our equation. Now we're looking for x and we were given y. So let's plug that in for y and let's get 40 is equal to 32 over x. Now again, 40 equals 32 over x is a proportion. So we could write it as 40 over 1 equals 32 over x. And I'm going to use the cross products property this time. Remembering that I can basically multiply these two and multiply these two, and they should both be equal. Okay, so let's change back to green and remember that that is going to tell us basically that 40 times x is equal to 32. Now, since I have 40 times x, to undo this, I can divide by 40. So dividing by 40 here, and dividing by 40 here, and I get x is equal to 32 over 40. Now, 32 and 40 are both divisible by 8. 8 goes into 32 4 times and 40 5 times. So that should simplify to 4/5. That's the same ratio, 4/5. Now I'm going to let you do part E because it's very similar to part D. Okay, but basically, once we have the equation, we can just plug in whichever value they give us. Remember, it's always x comma y, and then we can find the other one. All right, now let's scroll down to number 3. It says find 5 points that satisfy the equation y equals 18 over x, then use this Desmos link to enter the points into the table and the equation below it. Make sure the points are on the equation's graph. Okay, so let's plug in some points. It doesn't really matter what, but let's basically choose some x values and then we can find some y values. Now, if my equation is y equals 18 over x, I am going to try to basically, this is really big, but choose x values so that 18 divided by x is a nice number. I don't have to do that, but I want to because it just makes my life a little bit easier. So for instance, I could choose maybe x equals 1. If x equals 1, then y equals 18 over 1, which is 18. So 1 point would be 1 comma 18. If x is 2, then y would be 18 over 2, which is 9. So another point would be 2 comma 9. If x is 3, then y would be 18 over 3, which is 6. So another point would be 3 comma 6. So I've got 3 points. I really need a couple more. So let's choose 6. If x equals 6, then y equals 18 over 6, which is 3. So that's another point, 6 comma 3. And maybe just to be consistent, I'll choose x equals 4, and I'll get y equals 18 over 4, which is 9/2, which is 4.5. So another point would be 4 comma 4.5. And just to finish it off, even though we don't need this point, let's find it for x equals 5. You know, for x equals 5, we'd get y equals 18 over 5, which is, let's see, it will be about 3.6, I think. So that's the 0.5 comma 3.6. So I've got lots of, I just chose some x values, plugged them in, and then basically got the y value. All right, so let's look at this Desmos link and see if we can look at this. Okay, so it's pulling up here. I'm going to clear all my drawings and see. Well, actually, I'm not going to clear them yet. So here's the table, and I'm going to enter in my points. So one of the points was 1 and 18. Another point was 2 and 9. Another point was 3 and 6. Another point was 4 and 4.5. Another point was 5 and 3.6. And another point was 6 and 3. Okay, so those are my points, and my equation was y equals 18 over x. So I'm going to clear my drawings now. And I'm going to come over here, and I'm going to notice that here is my function, right? That's 18 over x. 1, 2, 3, 4, 5, and here are the points. I think one of them is actually way up here, but you can see that the points are on the graph. So it looks like I found points that are on the graph, which is what I want. Okay. Okay, so finally for number 4, we're kind of applying this a little bit more. So basically what we've done so far is we took an equation and we plugged in some x and y values to find the other value. We found a k value given an x and a y value, and we found some coordinates. And then we used an equation to find some points and make sure that they show up on, a graph, which they do, which is great. But now let's look at one practical example here. Okay, and then we'll be done. So number 4, it says the amount of time it takes to travel a given distance is inversely proportional to how fast you travel. Okay, so let's think about that for a second. That makes sense, right? Because if you go faster, it will take you less time. If you go slower, it will take you more time. So it makes sense that they're inversely proportional. Sound travels at about 330 meters per second in air. How long would it take sound to travel 80 meters? Okay, so let's see here. So we were given a speed 330 meters per second. So that is a speed. Let's call that S. And let's say that that was 330. Now we were also given a distance, right? Which is 80 meters. And let's call that D. So if we wanted to write an equation for the beginning, it says, distance, the time it takes to travel a given distance is inversely proportional how fast you travel. So basically, if you say my time is equal to the distance that I'm given divided by my speed, okay? And so that would make sense because this is meters per second and this is meters. So if you do meters divided by meters per second, that's actually the same as seconds, which is a little hard to show, but that's true. So if your speed was 330, then your time should simply be the 80 meters, your distance, divided by the 330 meters per second. And certainly it should be much faster than a second, because if you can travel 330 meters in a second, then you should be able to do 80 meters in much less. So 80 divided by 330 would be basically 0.24 repeating. That's supposed to be a 4 seconds. That's how long it's going to take you to travel 80 meters, or rather sound to travel. Now for B, how long would it take sound to travel 1 mile, or 1,609 meters? Okay, so the time would be 1,609 meters divided by the 330 meters per second, right? Our distance has changed, so now we have to divide by a bigger distance, or divide 330 by a bigger distance. So 1,609 divided by 330 is approximately 4.876 seconds. And finally, C, sound travels faster through solid matter. How fast does sound travel in ice cold water if it takes 3 seconds to travel 4,515 meters? So now we basically have our time, which is 3 seconds, is equal to our distance, 4,515, divided by our speed, and we want to know what our speed is. So what we could do is cross multiply and get 3s is equal to 4,515. And then I'm going to come up here because I ran out of space. I'm going to divide both sides by 3 and get S equals my speed, 4,515 divided by 3. So let's find that on our calculator. Actually, what is that? That should just be 1,505, I think. It is 1,505. So S should be 1,505 meters per second. Okay, so you can probably figure this out in a few different ways, but definitely possible to sort of use some of the inverse variation that we're talking about. So I hope that was helpful.